Something has begun to change on the planet beneath our feet. Quietly, almost imperceptibly, the Earth has been spinning faster, and the length of a day has been shifting in ways that scientists can measure with extraordinary precision. Atomic clocks, built to track time with near-perfect accuracy, have started to drift ever so slightly from the motion of the world below them. Satellites detect the difference down to the smallest fractions, and researchers continue to confirm that this is not an illusion, but a real change unfolding deep within the mechanics of our planet. If you enjoy calm journeys into the hidden forces of our pale blue world and stories that gently change the way reality is understood, consider subscribing to the channel and liking this video for more. Because to understand why the Earth is changing its rhythm, it is necessary to look far beyond the surface and deep into the silent, unseen heart of the planet itself. Now let the mind grow quiet and prepare to begin. On June 29th, 2022, a remarkable event took place almost unnoticed, yet on a planetary scale, it was historic. For the shortest measured moment since scientists began tracking Earth's rotation with atomic precision, our planet completed one full turn on its axis faster than expected. That day was 1.59 milliseconds shorter than a normal day. At first, such a number may seem almost meaningless. It is far smaller than the blink of an eye, too brief for human senses to ever notice, and easy to dismiss as insignificant. But when a world that has been turning for 4.5 billion years suddenly begins completing its daily rotation faster than at any other point in modern recorded history, the event becomes something far more important than a simple statistical detail. What appears at first glance to be a tiny difference in time begins to reveal a much larger story, one that reaches into the hidden systems shaping the motion of the Earth itself. Science rarely turns away from a whisper like this. If the change had appeared only once, it could have been filed away as a brief, technical fault, a tiny flaw in the machinery of measurement, something too small to deserve lasting attention. But that is not what happened. The shortening of Earth's day returned, then returned again, quietly repeating itself across the years with a consistency that was impossible to dismiss. Inside laboratories, the atmosphere began to shift. The question was no longer whether the instruments had made a mistake. The instruments were doing exactly what they were built to do. They were revealing that something within the planet's vast and hidden machinery was changing. And once that realization settled in, the mystery deepened. What invisible influence could urge a world of such enormous mass to turn just a little faster? What unseen hand could reach across oceans, ice, atmosphere, and stone and alter the rhythm of an entire planet? The answers did not lie in any single cause or within the comfort of a simple formula. Instead, the evidence pointed towards something far larger, a subtle rearranging of the great systems that shape the Earth itself, as though the planet's ancient inner clock had begun ever so slightly to beat to a different rhythm. To truly picture this change in the Earth's rotation, it helps to set aside the image of a digital clock and imagine something far larger. Imagine the planet itself, a vast sphere of rock, metal, water, and atmosphere, turning silently through the darkness of space, completing its long motion again and again as day gives way to night. From a distance, the rhythm of 24 hours feels fixed, almost eternal, as if the Earth were following a perfect and unchanging beat. But in truth, that rhythm has never been completely still. The length of a day has always shifted, if only by the smallest amounts, because the Earth is never moved by a single force alone. It is constantly being tugged, pressed, and subtly reshaped by influences from within and beyond itself. Sometimes its spin eases ever so slightly. Sometimes it quickens. These changes are measured in milliseconds, far too small for human senses to feel, yet large enough to matter when observed across years, centuries, and ages. For most of recorded history, the deeper pattern pointed in one direction. The planet was slowing down. Little by little, almost imperceptibly, the turning of the Earth was being restrained over immense stretches of time. One of the most important reasons lies above us, hanging quietly in the sky each night. The moon, through its invisible pull on the oceans, has long acted like a distant hand reaching across the surface of the world. As tides rise and fall, that gravitational force creates a subtle resistance, a drag so gentle that no person could ever notice it directly, yet so persistent that across millions of years it has slowed the spin of the Earth, millisecond by millisecond. Ancient coral fossils preserve a quiet record of time far older than any human clock. From the growth patterns locked inside them, scientists have learned that around 400 million years ago, a year on Earth contained more than 400 days. The explanation is both simple and astonishing. Back then, each day was shorter because the planet itself was spinning more quickly than it does now. Across immense stretches of time, that rapid motion began to soften. The moon, through its endless gravitational pull on the oceans, acted like a patient and tireless force, gradually draining a little of the Earth's rotational energy. Bit by bit, age after age, the planet slowed into a calmer rhythm. This long and steady deceleration was not unusual. It was the natural path scientists expected, a deep planetary trend unfolding over millions of years. And then around 2016, something shifted. What unsettled researchers was not a small irregularity, but the sudden reversal of a pattern that had seemed ancient, stable, and reliable. The data was checked again and again, compared, verified, and tested from every possible angle. Yet the conclusion remained. After ages of gradual slowing, the Earth had begun, however slightly, to accelerate once more. The planet was spinning faster. This acceleration was not the kind of change anyone could feel upon waking and looking out the window. It did not shake the ground, disturb the seas, or announce itself in any dramatic way. And yet, to the precise eyes of atomic clocks, laser measurement networks, and orbiting satellites, it was both clear and persistent. Year after year, the planet began producing days that were shorter than expected, each one setting new records in a pattern that could no longer be ignored. 2020 broke the record of its time. 2021 moved beyond it, and then 2022 pushed even further, casting the others into shadow. What made the mystery stranger was that the old forces responsible for slowing the planet had not disappeared. The moon was still there, pulling on the oceans with the same quiet strength as always. Tidal friction had not ceased its patient work. The ancient braking system of the Earth was still in place, still pressing gently against the planet's spin. And yet, despite all of that, something else had begun pushing in the opposite direction. strongly enough to challenge that immense and ancient resistance. This is where the real puzzle begins. The forces that may be urging the planet forward are hidden within a vast chain of processes, stretching from the cracking ice at the surface to the dark center, thousands of kilometers beneath our feet. On the surface, enormous sheets of melting ice are redistributing the planet's weight, subtly altering the balance of its rotation. In the atmosphere, shifting systems of pressure move across the globe and press invisibly against the spinning crust below. In the deep ocean, changing patterns of currents create their own delicate resistance, adding yet another layer to the planet's restless motion. And deeper still, far below anything human eyes will ever see, a vast ocean of liquid iron churns in total darkness, moving in ways that remain intimately connected to the rhythm of everything above it. Each of these forces is real. Each has been measured, tested, and confirmed by science. None of them belongs to speculation alone. And yet the true mystery does not lie in the existence of these separate pieces, but in the way they combine beyond sight. Somewhere within that hidden interplay, in the meeting point between ice, air, water, rock, and the molten heart of the Earth, the deeper answer may be taking shape. Scientists are now trying to understand how these enormous forces interact in the dark, far beyond direct human observation. The debate is no longer about whether the change is real, but about which mechanism speaks with the strongest voice in this acceleration, and whether the planet may be approaching an entirely new threshold in its rotational behavior. Yet beneath all the uncertainty, one fact stands with unsettling clarity. The Earth is no longer behaving in the way long-established scientific models expected it to behave. That matters more than it may first appear. The clocks that organize the lives of billions of people, the systems that keep satellites stable in orbit, and the vast technological infrastructure surrounding the modern world were all built around a quieter assumption. A planet whose motion would remain slow, steady, and predictable. But now those immense digital systems are beginning to fall slightly out of step. A subtle gap is opening between the absolute precision of atomic time and the physical time of the Earth itself. And within that widening divide lies a difficult decision, one that could force humanity to adjust the way global time is managed, with consequences serious enough to affect the fragile architecture of the worldwide internet. The story of this fracture begins, in a way, with a perfect invention, one so precise that almost no one could have imagined it might one day lead to a problem of its own. To the human mind, a millisecond feels meaningless. It is smaller than perception, too brief to carry weight, too fleeting to be felt. If a single millisecond vanished from an ordinary day, no one would notice its absence. Human life would continue untouched. But the Earth does not experience time as people do. It moves within a vast mechanical rhythm, a world of interlocked systems turning together like the parts of an immense clock. And when that rhythm changes, even by the smallest fraction, the effect does not remain isolated. It begins to travel outward. To picture this more clearly, imagine a wheel of enormous size turning in perfect balance. Every gear attached to it, every smaller mechanism, every delicate component has been designed to move in exact harmony with that central motion. Nothing is random. Nothing is allowed to drift. Now imagine that the wheel is nudged, only slightly, just enough to make it turn a little faster than before. At first, Nothing dramatic happens. No gear shatters. No machine collapses. But the balance begins to loosen. Each connected part starts to slip, almost invisibly from the timing it was built to follow. And that is where the danger lies. The longer this subtle mismatch is allowed to grow, the wider the separation becomes. What begins as a difference too small to feel slowly spreads through the whole system, placing strain on the invisible bonds that hold everything together. Over time, that quiet pressure can become far more dangerous than the original change itself, because the problem is no longer the speed of the wheel, but the growing instability of everything that depends on it. The Earth's rotation is that great turning wheel, and the systems attached to it are nothing less than the machinery of modern civilization, built on the assumption that time itself will remain precise, stable, and obedient. One of the clearest examples can be found above us in the silent network of global positioning satellites. These machines circle the planet at fixed altitudes and send signals toward the surface, each one timed with astonishing precision, down to mere nanoseconds. Their accuracy does not depend on the motion of the Earth below, but on the unwavering behavior of cesium atoms isolated inside carefully controlled laboratories. In that sense, they follow a clock far more rigid than the planet they orbit. If the Earth turns even a millisecond faster than those systems expect, the surface of the world shifts ever so slightly ahead of where the satellites assume it should be. The result is not an error measured in vast distances, but in small, creeping deviations, centimeters rather than kilometers. For an ordinary person walking down a street, such a difference would pass unnoticed. But in the dark expanse of the ocean, where ships rely on exact position to move safely through open water, or high above the ground, where aircraft depend on precision to hold their course, or inside operating rooms where robotic instruments must move with extraordinary accuracy, those few centimeters can become the boundary between control and danger. Financial markets form another delicate gear in this immense clockwork of time. Across New York, Tokyo, London, and Frankfurt, countless transactions are executed in fractions of a second, each one sealed with a timestamp so precise it reaches into the realm of microseconds. These timestamps are synchronized to a universal standard, a timekeeping system that does not care whether oceans shift or planets subtly change their pace. But if the world beneath these systems begins to drift away from that universal rhythm, then the meaning of those timestamps begins to erode. And when time itself loses certainty, even the systems that seem most abstract can begin to feel the strain. In an environment shaped by high-frequency trading, even a gap of a single microsecond can become the first hairline fracture in a much larger collapse. When countless transactions are being executed at extraordinary speed, certainty in timing is not a luxury. It is the invisible foundation beneath the entire system. The moment even the smallest ambiguity enters that structure, order can begin to give way to instability. Electrical grids offer perhaps the most physical and immediate example of this same fragility. Vast generators push energy through the arteries of nations at tightly controlled frequencies, usually 50 or 60 cycles per second, maintaining a rhythm that must remain remarkably steady. Across entire continents, grid operators rely on synchronization with universal time to keep power flowing smoothly between enormous interconnected regions. If time itself begins to drift, then the systems responsible for balancing electrical load drift with it, and what was designed to remain stable can begin to sway toward danger. For a long time, details like these were treated by scientists and engineers as distant technical concerns, important perhaps, but manageable, the kind of hidden precision the modern world quietly depends upon without ever needing to notice. Researchers had long understood that the Earth's rotation was never a perfect metronome. The cold, unwavering rhythm of atomic clocks and the slower, more irregular motion of the planet were never truly identical, and sooner or later, that gap had to be corrected. That is why the idea of the leap second was created. From time to time, a single second would be added to official universal time, a small adjustment meant to bring human timekeeping back into harmony with a planet that was gradually slowing down. For decades, that logic remained simple. The Earth slowed, and time was added. The correction always moved in one direction, like a careful hand making tiny repairs to a clock that was losing pace. But then the pattern changed. The direction of the drift no longer followed the old expectation. The planet began to turn slightly faster, and for the first time the clocks were no longer running ahead of the Earth. They were falling behind it. That shift has led science and technology into unfamiliar territory. Since the modern system of global timekeeping was established, officials have never faced the need to remove a second instead of adding one. And yet, that is now the possibility being discussed. A step known as a negative leap second. On paper, it sounds almost trivial, the deletion of a single second from official time. But for the engineers responsible for the foundations of the digital world, that missing second is anything but small. Many have warned that such a subtraction could become one of the most dangerous timing events modern infrastructure has ever faced. A global network can tolerate delay more easily than reversal. But removing even 1 second means forcing systems everywhere to confront something they were never built to expect. Time itself appearing to skip. At first glance, removing a single second from official time sounds almost harmless, the kind of adjustment most people outside the field would never imagine could carry any real danger. But the truth is far stranger and far more unsettling. Before stepping deeper into that possible disaster, it becomes necessary to understand the instrument that first noticed this silent acceleration of the Earth, the precise observer that caught the planet drifting from its expected rhythm. Because the story of how this change was detected does not begin in space, or in the oceans, or even in the core of the Earth. It begins in something unimaginably small, within the steady pulse of a single atom. Before 1955, even the finest clocks on Earth were still imperfect. The best of them could gain or lose about a second over the course of 300 years. For ordinary human life, that level of precision seemed extraordinary, almost flawless. But on the scale of planetary science, where tiny deviations can grow into meaningful truths, it was not nearly enough. The Earth demanded a more exact witness, so physicists built something entirely new, the first atomic clock. Its principle was elegant in the way the deepest scientific ideas often are. Human-made mechanisms can drift, springs weaken, gears wear down, but atoms follow their own internal rhythm with astonishing loyalty. They do not grow tired, and they do not improvise. In that sense, the foundation of the atomic clock rested on a simple belief, one that would go on to reshape humanity's relationship with time. time itself. Atoms do not lie. Wherever it exists in the universe, every atom of the same element follows the same internal rhythm. In the most precise clocks ever built, the element of choice is cesium-133, whose atoms oscillate 9,192,631,770 times each second with astonishing consistency. No hesitation, no drift, no exception. That unchanging rhythm became the new definition of a second. Time was no longer tied to the imperfect motion of the Earth in space, nor to the slow fatigue of pendulums and mechanical gears. It became something colder, more absolute, and far more exact. The counted vibration of a single atom, repeated more than 9 billion times. The result was a machine so precise that it could pass for almost eternal on a human scale, losing less than a second over hundreds of millions of years. And once scientists gained access to that degree of certainty, they realized they could do something entirely new. For the first time, they could measure the planet itself with breathtaking precision, tracing the Earth's rotation millisecond by millisecond. What emerged from those measurements was unsettling from the beginning. The planet did not spin with the smooth, flawless grace people once imagined. Its rotation was restless, uneven, and constantly shifting. Season after season, the data revealed a world in motion far more complex than any simple model could suggest. As vast atmospheric masses in the northern hemisphere migrated toward the poles during winter, the planet's spin subtly changed. When summer returned, the rhythm shifted again. Deep earthquakes disturbed the sea floor and made tiny but measurable adjustments. Great storms pressed against the surface with enough force to leave a detectable mark. Even massive changes in ocean circulation, such as El Niño, or the slow accumulation of snow and ice across high latitudes, left faint signatures in the rotational record. Researchers learned to track all of these influences with extraordinary care, measuring them, modeling them, and folding them into their calculations. For a long time, the system held together beautifully. Every fluctuation had its place, and every disturbance could be woven back into the clockwork of understanding. For years, those occasional leap seconds kept the gap between atomic time and the Earth's slower, heavier rotation within a manageable range. The difference was small enough to correct, small enough to live with, and for a long time it seemed that the balance could be maintained indefinitely. Then came the data that followed 2016. The familiar fluctuations were still present, the seasonal rises and falls, the subtle disturbances scientists already knew how to track. But beneath all of them, another signal began to emerge with unsettling clarity. The average length of a day was shrinking in a way that could no longer be ignored. This was not a random anomaly, nor a passing irregularity that would smooth itself out with the changing seasons. Year after year, the numbers leaned in the same direction, forming a pattern too persistent to dismiss. As expected, the first reaction within the scientific world was skepticism. Instruments were checked and checked again. Calibration errors were hunted down and ruled out. Data from atomic clock networks separated by continents were compared through repeated cross-reference. The International Earth Rotation and Reference System Service, the organization responsible for monitoring the planet's rotational behavior on a global scale, carried out its deepest analyses. The conclusion was as stark as it was unsettling. There was nothing wrong with the instruments. The signal was real. And what made that signal so disturbing was not simply that the Earth was speeding up, but that the acceleration refused to fit inside any single known explanation. Tidal friction from the moon was still working exactly as expected. Seasonal atmospheric shifts had already been accounted for. Ocean currents, powerful storms, and deep earthquakes had all been measured and folded into the models. Yet even after researchers removed every known influence from the data, something remained behind, a stubborn residue of acceleration that would not disappear. Beyond every cataloged cause, beyond every measured and familiar force, there was still another push, something unseen, still driving this immense planet quietly forward. Scientists were now staring at a measurement so immense and so persistent that none of the mechanisms already on the table could fully explain it. In science, this is often the moment when a mystery becomes both more fascinating and more unsettling. Because the more researchers examine the atmosphere, the oceans, and the vast ice sheets spread across the continents, the more the answers seem to retreat from the surface. The explanation was not waiting in the clouds, nor hidden in the motion of waves. It was leading them downward, far below the familiar skin of the earth, into a realm no human being has ever touched. To follow that trail, they had to turn their attention toward the inaccessible dark, more than 2,000 kilometers beneath the surface, where no instrument can survive for long and no direct observation is possible. In that buried world, beyond the reach of drills and machines, a vast ocean of liquid iron moves slowly through the dark. It does not resemble any ocean known at the surface. Its currents flow under pressure so immense they would crush ordinary matter beyond recognition. In that hidden sea, the churning metal is not passive. It is one of the great unseen forces shaping the behavior of the world above. If it were possible to descend through the rocky shell of the planet, the journey would pass first through layer after layer of rigid stone, then through the upper mantle and the lower mantle, sinking ever deeper into heat, compression, and silence. And eventually, far below everything familiar, you would arrive at a place where pressure rises to such extraordinary levels that matter itself is forced into forms that could never exist at the surface. It is there, in that unreachable darkness, that one of the strongest candidates for this planetary mystery may be waiting. When that descent finally reaches the outer core, the journey has already carried us to a depth of roughly 1,800 miles, with an immense region still stretching far beyond. This hidden layer is made mostly of molten iron and nickel, a realm of extreme heat so intense that it rivals, and in some ways surpasses, the temperatures found at the surface of the sun. Yet this is not a fluid like water, and not an ocean that rolls in familiar waves. It is metal, compressed, heated, and energized into motion under conditions so violent that ordinary comparisons begin to fail. There, between the relatively cooler base of the mantle above and the blistering heat of the solid inner core below, vast currents begin to move. These are not gentle drifts. On geological timescales, they are astonishingly dynamic, flowing over distances of many kilometers each year while carrying immense electrical charge through the darkness. As this liquid iron shifts and swirls, it powers the process known as the geodynamo, generating electric currents deep inside the planet. Those currents, in turn, create the Earth's magnetic field. and that magnetic field does not remain trapped in the depths where it is born. It rises outward, threading through the mantle, passing the fractured crust, and extending far into space. There, it forms the enormous invisible shield that deflects charged particles from the sun and protects the atmosphere from being stripped away. Without that boiling ocean of metal deep below, the planet above would be far more exposed, and perhaps no longer hospitable in the way it is now. In the most direct sense, the dark heat of the outer core is one of the main reasons Earth remains a livable world. But the role of this molten iron is not limited to creating that protective shield. It is also physically connected to the motion of everything above it. And this is where the mystery of the planet's strange acceleration begins to deepen. The liquid outer core does not rotate in perfect lockstep with the mantle and the rigid crust above. The connection between them is real, transmitted through enormous pressure and powerful electromagnetic forces, but it is not absolute. The outer core retains a degree of independence, its own subtle rotational behavior beneath the world we stand on. When the patterns of flow inside that metallic ocean begin to shift, when great columns of iron rise and fall, and when the deeper currents reorganize themselves, they can apply a measurable torque to the layers above. As researchers studied the evidence from these hidden transformations, a pattern began to emerge. Again and again, disturbances in the Earth's rotational record seemed to echo changes linked to this deep exchange of energy. Fluctuations in the magnetic field appeared to correlate with the small but stubborn variations in the planet's spin. When the field trembled in certain ways, the Earth's rotation seemed to respond, subtly quickening or easing in return. The full mechanism remains unresolved, and it continues to stand at the center of scientific debate. But one conclusion has become increasingly difficult to avoid. This dark ocean of liquid metal, buried far below the reach of human sight, is not isolated from the fragile world above. It is shaping it, quietly, continuously, and perhaps far more directly than anyone once imagined. Geophysicists now increasingly view this immense activity within the core as one of the main drivers behind the long-term changes in Earth's rotation. The strange acceleration that became noticeable around 2016 aligns strikingly well with the magnetic data recorded by satellites during the same period. The timing is difficult to ignore. As circulation patterns within the outer core began to shift, the planet's rotational behavior seemed to shift with them. To many researchers, this parallel does not look like coincidence, but like the visible surface trace of a much deeper process unfolding far below. And so, beneath the calm rhythm of ordinary days, the Earth continues its silent conversation with forces too deep, too vast, and too ancient to ever be fully seen. What seems from the surface like a world of perfect stability is in truth a living system, always shifting, always responding, always carrying hidden movements within its dark interior. Somewhere below the oceans, below the continents, and far beneath the reach of light, the planet is still adjusting its own mysterious rhythm. And perhaps that is the most humbling truth of all. Even on the ground beneath our feet, on the world we imagine we know so well, there are still forces at work that can quietly reshape time itself. So as the night grows still and the earth turns on through the darkness, it may be worth remembering that we are all resting on a planet far stranger, far more alive and far more mysterious than it first appears. And now, as the world grows quiet and the hours drift softly into night, let the mind rest and the questions fade into the dark. Good night, and may the turning of the earth carry you gently into peaceful sleep.